Good morning, guys. I trust you are doing well. I want today to talk to you guys about how stars classified. Okay, you guys have already learned what are the different features of the sun, and now we get to another lesson where we'll be talking about how stars are classified. So, can you take your science hardcover book and you go exactly at page D38? You go at page D38, and that's where we are going to learn. If you are ready, guys, we can start. So first of all, put in your mind that in this lesson you guys will learn about the way stars are classified, and you will also learn how a star starts life and how it ends up dying, if you can say it like that. Okay, so first thing, when you look at the sky at night, do you notice that the stars are different, or you just see them the way they are? Yes, you should know that stars are different. Scientists have found a way to classify stars. Okay, so they have been able to identify the different characteristics of stars and they have been able to classify them following these characteristics. So they classify stars according to or by the size, the magnitude, the surface of temperature or just the temperature, and by the color. So let's now talk about classifying stars by the size. The largest stars are called supergiants. Okay, for example, you have the sun. The sun is a supergiant star. The smallest ones are called neutron stars. Okay, just like neutrons we learn in chemistry for bigger ones. So the smallest one are called neutron stars. Now, talking about the magnitude of stars, you guys need to know that magnitude is also called luminosity. Luminosity. What is luminosity? It just describes how bright a star is. Okay? So scientists use two concepts. First concept is called the absolute magnitude, and the second one is the apparent magnitude. What do they understand by absolute magnitude? It's simply absolute magnitude is it's what tells us the true brightness of the star. Okay, absolute magnitude tells us the true brightness of the star, while the apparent magnitude is how bright the star appears to us on Earth. You see the difference? Yeah. So how the star appears to us on Earth, that's what we call apparent magnitude. But the absolute magnitude is just how the true brightness of the star. Okay? So closer stars appear brighter than further one. When you look at the star on the sky, when you look at the sky, you'll notice that there are some stars that look brighter. These brighter stars are those who are closer, and those who are very far are not that brighter. Okay, because we need to drink water. Now let's talk about the third characteristic. We've talked already about the size, the magnitude. Now let's talk about the temperature and color together. The temperature and the color stars. Why do we put them together? Because they always go together. Okay, the color changes in relation to the temperature. The color of the star changes in relation to the temperature. Here is how you can understand. Hottest stars are mostly blue. Okay? Hottest one are mostly blue. Now, coolest one are red. That's really crazy, right? Because we are used to have red for hottest and blue for coolest, but for stars it's the opposite. Hottest stars are blue and coolest stars are red. So anytime you'll be observing the sky, if you see a blue star, just put in your mind that that star is hot, super hot, than the one that looked red. Okay. So in order, if we want to order stars from the coolest to from the hottest to the coolest, you will have blue stars, white stars, yellow stars, orange stars, and finally red. Which one are the coolest? The coolest. Okay. Now let's talk about how stars change. So first of all, a first word is nebula. What is nebula? Nebula is just the way a star begins its life. So a typical star begins life as a nebula. And secondly, some particles clamp together to form what we call now protostar. It changes from nebula to protostars. What happened to from for it to move from nebula to protostar? It just particles clamp together, okay, and it becomes a protostar. And now when the particles become hot enough, the star begins to shine. Okay, so you understand that when it was nebula to get to protostar, it was not shining yet because it wasn't hot enough. Now it gets hot enough, and then it begins to shine and to release energy. Okay, so it shines steadily for billions of years. Then now it begins to run out hydrogen. Okay, one of the gas it has, because stars have two gases, helium and hydrogen. Now it begins to run out of hydrogen, and the star expands. Okay, the star expands and becoming a red giant. Then its corona expands even more. Okay, and after that, after the corona expands even more, it becomes what we call a planetary nebula. Planetary nebula. I want you just to consider what I'm explaining you in this page. Okay, this is page D40. So you will see all the different steps. You first have nebula here. This is nebula. Okay, nebula it's one, and then two you have protostar. Protostar is right there. And thirdly, you guys have main sequence star. So you can read all the description there, okay? And you continue number 4, it's another one, and you can continue reading, but I'm just explaining you so you may understand. Okay, so I say the corona will expand even more and it will become a planetary nebula. And all what will remain from that star, it will be a very tiny white dwarf. We call it dwarf. Okay, so that's all will be left from that star. It's this one, it's point number 7. It's this very small point there. This is what will be left of the star after it expands even more and the corona gets even uh, expand even more than it was before. Okay, so this is what you guys can know about the star. Okay, so don't forget stars begin like as a nebula, and then it turns into a protostar, and then particle become to clump together. When it become a protostar and it gets hot enough, then it begins to shine and to release energy. Okay, and then it will start to run out of hydrogen, and then the star expands and become a red giant, and the corona will expand even more, and finally the planetary, it will become what we call a planetary nebula. And finally you have a white dwarf, a very tiny white dwarf that will be left from that star. So thanks for watching this video. If you have any question, don't hesitate to call me or to send me a message. Okay, so I say thank you guys, and I'll see you next time. Bye bye.